Good evening, this is Mr. Wintermelon, and we have come to the last video on the chapters of movements of substances, where we will look into factors affecting the rate of diffusion as well as osmosis. In all honesty, this is more of a supplementary video. The things that we will talk about, it will be good to know, but not so much of must know. There are 4 factors which I'm going to talk about. The first factor is the temperature of the particles. As you have seen in the simulation, when I increase the temperature, the movement of the particles will be faster. Therefore, the rate of diffusion will be faster. Next is the size of the particle. The larger the particle, the slower the rate of diffusion, especially when there's membrane, where they will have a much problematic time moving across the partially permeable membrane. Next is the concentration gradient. So the steeper the concentration gradient, the faster the rate of diffusion or osmosis, which is what you can see in the graph. If the concentration gradient is very similar, the rate of diffusion will be slower as compared to when the difference between the concentration of 2 regions is higher. Finally, something which we will go into greater depths, which is exposed surface area to volume ratio of, let's say, a cell or a tissue. So you might be thinking, what is it? So consider I have 3 cells with 3 different shapes. The first one is a bit cubical, second one is a bit cuboidal, third one is very elongated. Which of the following shape will allow the greatest rate of diffusion and osmosis? And why? So the why you probably can guess, oh, because it have a larger or smaller surface area to volume ratio. So let us look at the detailed explanation. So consider this. Just now the cells are in 3D, which is a bit difficult for me to animate, so I have converted them into 2D. And a simplified version can be found on the right hand side. This is how the first cell will look like. The second cell is a bit elongated, followed by the third that is very elongated. So as the cell become more elongated, the surface area to volume ratio actually increases. There are more surface area for molecules to enter and exit the cell. So if you look at the cell, the starting cell, you can see that there are 14 areas which the molecules can enter and exit, as compared to the last cell, the elongated one. Now, there's 26 units of space where molecules can enter and exit. Hence, as the cell becomes more and more elongated, the surface area to volume ratio will actually increase, and the efficiency in the rate of exchange of substance will also increase, which means the rate of osmosis and diffusion will be faster. And this will be the end for this chapter. I might add in a few more supplementary videos, so stay tuned.